A new area clearance strategy specifically for the machining of blisks and impellers has been introduced for PowerMILL 2013. This new roughing strategy is based on a trochoidal motion to clear away the material between the blades. Presently, this new trochoidal method does not support splitter blades. Let's take a look at this new trochoidal method on the example part displayed. If we open up the settings for the blisk area clearance strategy and take a look at the machining page, we can see that under the method option we have a new trochoidal method. To go along with this new method, we also have a new set of parameters for the trochoids themselves, and we have the radius of the trochoid that we would like to use. This is the radius in the corners of the trochoid, and we also have a minimum radius setting, which is the minimum radius we will allow the trochoid to use. So this comes into play when we are trying to go through narrow sections between blades, for example. And then we have the connection clearance. This is the retract distance for the return move of the trochoid, where it's actually not cutting any material, it's just getting back to the start of the next trochoidal pass. And finally we have an overlap, which is in conjunction with the connection clearance is the distance that the trochoid will overlap the previous pass. So let's calculate the toolpath. The rest of the parameters are the same as previously in previous versions. We have to define the step over, the step down of the trochoidal pass, and also whether we want to merge from top to bottom of the blades or use offset up style or an offset down style as before. So you can see now it's starting to build up the trochoidal path using a merge option in this case. If I just switch that back on and close our strategy form. So it's very difficult to see what's happening there because there's a lot of toolpath on the screen. So let me just deactivate that toolpath and activate one that has been pre-created, which is just a single pass. So let's simulate that from the start so we can see the actual motion, the trochoidal motion, and then play that simulation. So we can see now it's working its way up the blade using that trochoidal motion. Now you'll notice that depending upon the step over we've defined, it may also introduce some circular moves to pick away at the next trochoidal pass to make sure the tool is not getting overloaded at the start of the next pass. So to finish off, we'll simulate from the start again, this time with the complete pass, and then we'll go across to the high resolution view mill and simulate from the start again.